Okay, so I'm going to make a video about kind of wrapping up polymorphism. I'll just say right away that I'm going to use a lot of the examples that were from Dr. Lewis's video. I'm going to try and some of this explanation will be similar to what she explained because I think it's done so well. So I really highly encourage you just go back to the other video and really watch through the whole thing. And I've linked some sections. Maybe go back to at the top of this polymorphism section. There was a link to a portion of the video. I really encourage you to do that. But I will give my own kind of take on it and what I really like out of the video, and why I think it's such a good example here. So we'll start with she defined 3 classes. We had the cat, we had the tiger class, and we had the cartoon tiger. The tiger class extends the cat, and the cartoon tiger extends the tiger. What I really love about the way that this is visualized is there's a method for sleep in the cat class, but there's not one in the tiger or in the cartoon tiger. But we can see that there is the say hello method is created in the cat class, in the tiger class, and in the cartoon tiger class, and whereas swim is only defined within the tiger class. So that leads to this kind of explains a lot of it's a great example to show how these things are going to work. So if I were to make like a cartoon tiger object, it's going to be called CT, and it's going to be a new cartoon tiger. If I call this method ct.sleep, here's how it's going to work in polymorphism and in inheritance. What it's going to do is it's going to look for sleep within cartoon tiger. It's going to look for that method there. If it doesn't find it there, which it won't because it doesn't exist in cartoon tiger, it's going to work its way up the methods, or it's going to work its way up the classes. It's going to look in tiger, say, hey, it's not there. It's going to work its way up into sleep, and it's going to say, oh, hey, sleep is there, so I'm going to run this method. If we took the same thing and did ct.sayHello, this would work a lot differently because it's going to look within the cartoon tiger class. It's going to find the say hello method here, and it's just immediately going to run this because it's this, and this is what we're calling as it's overriding. It's overwriting the previous examples, the previous methods. So yeah, whereas for sleep there was no previous methods to overwrite, and now we actually have something to overwrite. So ct.sayHello will print this out. Okay, so there's a lot of great things about doing this. One of the great things about this whole idea of polymorphism, like as from an application, I'm just gonna go back on that one. From an application standpoint, is that we can store like objects together, and they are going to, so we can actually store cats, tigers, and cartoon tigers all within the same array list. So we can make an array list. Oh, I think I'm running out of space there. We can make an array list. Let me just pause the video here real fast, and I'll just write some stuff up. All right, so what I did, I don't know, I can't change this ugly or kind of cartoony font, but here's where we're at. So we made an array list of cats called kitties. It's a new array list. Well, let's make sure we get our semicolon before someone writes me angry emails. We'll have a semicolon there at the end. So we have a new array list called kitties, and it's meant to be filled with cats. Now the interesting thing is that we can actually add different types of animals to this. We don't actually, even though we were adding cats, even though we declared this as being filled with cats, we can add cats, but we can also add tigers, or we can add cartoon tigers, because all of these, because a cartoon tiger is really an example of a cat, and a tiger is an example of a cat. So we can store all these things together. But the thing, so that's going to work great. And so if we were to do something like a loop through the entire thing, loop for cat, C, and kitties, and we could do something like this. We want to say like, for every cat that's in there, we want to say like c.sayHello. That method's going to work just fine because sayHello is defined for capital H on here. Again, no angry emails. We're going to put sayHello because that exists in all of the classes. So Java's going to be okay with this, and it's going to say that we don't have any problem with running sayHello because each one of these is going to implement it differently, and the different animals stored inside this kitties array list would work differently, but it's okay because everybody has this method and we can all have access to it, so Java's not going to give us an issue. We could also do something like c.sleep because again that's defined within the superclass, so it would try and implement it for so this would work because all of the cats are guaranteed to have some form of sleep. However, what wouldn't work is the C swim. Because you can think about, like you said, that this thing is full of cats. And so this is actually going to give you an error right away because you said this thing is full of cats. But cats do not have the method swim. So when we try and call that for the entire array list, there's going to be an issue. So in general, this happens when we do something like if we said, yeah. So that's going to be an issue. I'm going to take a quick break here. So coming back, like we said, this one, so the swim method would not work because it's not existing for all cats. And so I want to kind of point your attention over here. So this set of declarations would work. We could actually we could declare a cat called C, and we could declare it to be a new cat. And we could declare D to be a new tiger and E to be a new cartoon tiger. This actually is going to work because a cat is a type of, a cartoon tiger is a type of cat. So we could do this. But if we were to, and this basically was happening inside of our array list, because inside of our array list, when we run this line, where we set up kitties to be a new array list, we are filling it with an empty set of cat objects. So even though we haven't, as soon as we create the array list, there's going to be a bunch of null cats in there, just kind of like temporary placeholders in there. And then as we are declaring those, this kind of what we're doing right here. Like this is a space, I don't know if this is a great explanation. This is a space within the array list. Maybe cat C is like our temporary cat that's created within the array list. Initially it's null, but on this line, I'm going to set that first cat. I'm going to be equal to new cat. So this is basically the declaration that I'm making. Saying that space in the array list was previously just a null cat. Now we've kind of assigned it to be, we've initialized it to be equal to a cat. On the other hand, in the second space, I'm just using a placeholder variable called D here. And that second place in the array list, we had a null cat, and we're setting it up to be equal to a tiger. And same thing here. In the third space, we might have had a null cat called E, and we're just making it into being a cartoon tiger. And so this kind of shows that when we can declare objects like this, but we're going to lose access to anything that is explicitly and only a tiger. We're going to have access to the variables and the methods that are existing within the cat class, but we're going to lose things that are explicitly connected to, say, a cartoon tiger or to a tiger. Hopefully that makes sense. So the one thing we could do here, like if we wanted to get back some of the features of a cartoon tiger, is we could say cartoon tiger. If we want to make like a new cartoon tiger, I'm trying to be creative, but I'm not going to be. We could say cartoon tiger is equal to, and then we could cast E into being a cartoon tiger, and that would get back some of the functionality that exists within a cartoon tiger. This is basically promising Java that the thing that we stored inside E can be converted into a cartoon tiger. I know you said it, I know that we said it's a cat, but I promise you it's really a cartoon tiger, and we can cast it from one type of thing into the other. So I'm going to stop that there. Again, I really recommend you look back to Dr. Lewis's video. Does a great job of explaining this. I hope that I did some approximation of getting some of that information across.